solving 2 and 3, we get V3 equal to, so let's solve and see what are the values. So V2 comes out to be 2.476 volts and V3 comes out to be minus 9.524 volts. So these are the values of V2 and V3. Now the question was to find current through 1 ohm resistance. This is my 1 ohm resistance. Let us find current through it. For that I will quickly redraw that one single branch so that we can easily define the current through this resistance. This is 1 ohm resistance. Now we had voltage V1 on the left hand side, V2 on the right hand side, and this was 8 volts battery. The direction of the current is not mentioned, so I can go for any direction I want. So let us stick to the direction that we had taken when we were writing KCL. We had taken the direction towards left. So in that case, the current through 1 ohm resistance I1 comes, on positive polarity side the total voltage is V2 plus 8, minus on this side it is V1, and this will be divided by 1, which is the resistance 1 ohm. Now this will be nothing but V2 is already known to us. It is 2.476 plus 8 minus V1. V1 is nothing but V1 we had obtained earlier. It is equal to 10 volts. So V1 is 10 and the resistance is 1 ohm. So this gives me I1 directly. It will be 8 plus 2, which is 10.476 minus 10, that will be 0.476 amperes. So that becomes the final answer for the current through 1 ohm resistance. So this was very interesting question where we used both the points together. The point number 1 was that there's a voltage source between a node and the ground. In that case, the value of that particular node voltage will directly be the value of the voltage source. And second, there was a voltage source between the two nodes, so we had to apply supernode concept. You had to be careful with this branch of 8 ohm that was between V2 and V3. We did not consider this branch when we were writing KCL at supernode, and when we write the second equation, it simply becomes V2 minus V3 equal to 12. And hence the conclusion from that second point is that this 8 ohm resistance, which is connected between V2 and V3, simply becomes redundant. So whenever there's a branch, there's resistance coming in parallel with a voltage source between the two nodes, this resistive branch becomes redundant. It will play no role in the values of node voltages. But please remember that when I say that it becomes redundant, doesn't mean there is no current flowing through it. If I want, I can now find the current through 8 ohm resistance as V2 minus V3 upon 8. Or if the current is defined to be flowing towards left, it will be V3 minus V2 upon 8 and so on. We know the values of V2 and V3, and hence I can find out the current flowing through 8 ohm resistance also. So when we say that it becomes redundant, with what respect it becomes redundant, that it will never come in the picture when we solve for the node voltages with the help of KCL equations. We get V1, V2, V3 without considering this 8 ohm branch.